In this video, we will see how to make a half bridge inverter in LT-Spice. I don't want to waste time making circuits here. Let's see how the circuit works, and I'll show you all the parameters which I have used, and then I'll simulate and show the things. Okay. Particularly, this ground should be, people think that this should be here, but this ground should be actually here, because the way it works is the current flows through this when this transistor is on, and this is the loop, and the ground is here. So the current flows like this in positive half cycle, which means when this is turned on, and current flows in this way when this transistor is on. That means this transistor and this transistor should not be on at the same time, and current will reverse when this transistor is on and when this transistor is on. Okay, so that's how it should work. So the main thing which we have to deal with is the base voltage which we are giving here. Okay, see the base voltage I've given initial 0, V on 2.5, you can give from above 1.8, whatever the values, and rise time, fall time, you specify this, don't give it 0 because it will take some default values. Then T on 0.5 milliseconds, 1 kilohertz input signal I have taken. Okay, then here the same values but with the delay of 0.5 milliseconds, which means this base voltage, this base voltage, and this base voltage will be in 180 degree phase shift. Okay, and the inductance can be anything about this value 100 millihenry. Okay, let's simulate and see. Yeah, let's see the voltage output. You just see it is 25 and minus 25, and let's see the base voltage which I have given. Okay, this will overlap. We will go here and split them up, go to plot settings, and then add plot plane, one more plot plane, which I'll drag this and put it here, drag this and put it here. See the 180 degree phase shift in both the signals, and see the output voltage. And if you want to see the output current, I'll show that also. Just press on this and you will get output current here. This is a triangular wave because of the reason that this is an inductive load, not a resistive load. If it was an resistive load rather than inductive load, then it would be as similar as your output voltage. The current would be a square wave. I didn't show the simulation command. I can show you that. This is the simulation command. The transient response from 90 milliseconds to 100 milliseconds with 1 millisecond, because the signal which I have given is 1 kilohertz and it takes 10 cycles. That's it. A very important thing that you have to notice is this ground. Okay, this doesn't have a common ground, so we must give this negative terminal to this, because this is the emitter terminal and this is the base terminal, and this should be connected like this. This is why the isolation is usually needed when we supply base voltages. Okay, these two emitters connection should be like this. This is how it works. Okay, thank you.